Alrighty, here goes. So again, I'm not here today, obviously, but I was going to pop this video in and move us along. So I'm not for sure why that keeps showing there. I want to see this anyway. So first thing we need to do is address a little bit as far as to do these problems. We have to go through. I'd walk you through the chapter 3 worksheet that you have already filled out. Most of you have. Many of you have. I don't know which word applies there. However, I apologize because this is the one that I wanted to get out, but evidently I have a different one in the packet. But here we are. Here we go. We need to talk about, when we talk about a distribution, we have to describe the distribution using our SOX. Okay, SOX stands for shape, outliers, center, and spread. Those are the things that we have to address when we describe a distribution. Okay, so we talk about the words that we need for shape. Okay, so if we see something like this, okay, that if we split it down the middle, it's got the same on both sides. This is what we call symmetric. Okay. Another shape that we need to understand, again, if I started with this set of data here, okay, but I threw some more stuff down here to the right, okay, I have put a tail on this distribution. So here's my tail, okay, the direction of the tail is the direction of the skewness. So this one is going to be a skewed distribution. This one is skewed to the right because that is where that tail is located, okay. Likewise, the next thing that we have to be able to describe, and again, if we started with something that was roughly the same, didn't do a very good job there, but then we stuck some information down here. Here's the left, okay? Here's my tail, so this is going to be skewed left. So those are words that we use to describe shape. There's another one that we also use, okay? This would be uniform. So if let's say I rolled a die 100 times, since every side of the die has an equal chance of happening, I should have over 100 chances, roughly equal outcomes as far as 1, 2, 3, 4, 5, 6. That would lead to a uniform distribution. Okay, and those are the words that we need to. These would all be classified as unimodal. Okay, uni is my prefix for one. Mode means most frequently occurring. So all of these are going to be considered unimodal because it has one distinct peak in the middle, okay? One general peak to it, okay? This one's not gonna be considered unimodal, okay? Because it doesn't have that distinct peak to it. So, but we also have another word in here that we need to be able to hit to and understand, and that would be bimodal, okay? Bimodal is going to be having two distinct areas, okay? Two distinct modes. So that means that I would have a mode that is, sorry, I'm tapping my screen. I've learned that if I tap it too hard, it's kind of harsh in the recording, but there we go. Has two distinct regions, okay? So bimodal. Those are all the words that we need to understand for describing a shape, okay? The rest of these are going to be relatively easy. The center is the approximate middle. And the spread is going to be max to min, or max minus min. Okay, it actually equals some number, or you could just describe it in words too. I'm fine with min to max. All right. So that's what we're looking at as far as words that we have to be able, things that we have to be able to use to move on there. Now, there was some other things in here as far as median and things like that. I'm not for sure what happened. Mean and median, again, understand, and this is the part that differs from what you turned. This is what differs from what I gave you. So I'm not for sure if those are in here or not, but the mean is going to be my middle by average. My median is my middle by position. So here I'm going to sum all the numbers and divide by the number of numbers. Wait, I know I'm talking fast, so I guess the good thing about video is you can pause it, okay? So this is going to be sample size plus 1 divided by 2. That's going to how I find my middle position. So I can do it that way. And we'll talk about that more when we roll to the other side. Anyway, so that was the intro that we had to get kind of talked about to get things moving. So now let's flip over to our odd problems and actually work on that, and we'll move forward with this. Okay, so in number 5, we're trying to describe what would we expect to see as far as and actually uniform, unimodal, and bimodal. We've talked about all those. We talked about symmetric, and we talked about skewed. So we have that. The number of speeding tickets each student in a senior class of college has ever had. So we'll kind of give ourselves an idea of what that might look like, and the fact that we could draw ourselves on what we would expect that to look like. We'll have a few students that have 0 speeding tickets. Well, I don't know. Maybe that would increase for 1 speeding ticket. I have no idea. But there's 2. Here's 3, here's 4, here's 5, and that is going to wane down here until we got the super lead foots out here at 9. I don't know. Okay, but that's what we'd expect to look for. Anyway, so when we describe that, we'll describe that as unimodal. This is skewed right. Okay, because again, we're looking for where that tail occurs. My tail is right here. Okay, it is skewed right. A few people. I guess it helps if I put the word people in there. We'll have many tickets. I mean, we're going to have, most people are going to fall within 0 and 1. Okay. But we could have a few people that have a lot. All right. Players score at a US Open. Now, here we have to understand how golf is scored a little bit. Okay. So how many people have the lowest score? Well, there's 1 person that's going to have the lowest score. Okay. And then we might have one person with the next lowest score too. And then there's going to be, we'll start in the middle. We'll start clumping that together until we have that. Okay. However, just like if we talked about run times, it's hard to run fast. So, but it's easy to run slow. So that means that I could be skewed to the right because I could have a lot of people that ran slow. Just like that's similar to golf. It's really hard to score a low score. So it's much, much easier, especially if you swing like I do, to have a much higher score in golf. So therefore, we're going to add, this is going to be unimodal skewed right as well. Okay. Easy to shoot a large number. And if we don't know how golf is scored, I guess that one probably is a little harder. All right, weights of female babies born in a particular hospital over a course of a year. Okay. Again, we're going to have a few premature babies. Then we're going to have a lot in the middle, and then we'll have a few heavier babies. So we're going to go with unimodal. I'm going to call this one symmetric. I'm going to say it likely follows a normal curve. We haven't got into a normal curve yet, I know. But we're just going to go with that. The length of the average hair on the heads of students in a large class. All right, so we got to think about the length of hair. All right, so you can obviously see the length of mine is pretty short. You go to Mr. Eckert, he's pretty short. Mr. Fike, yeah. All right, so we have we could have people with very no hair to very short hair, or we could a few in the middle, and then we could actually have a lot of people with longer hair. I hate to be gender specific, but a lot of guys have shorter hair, a lot of girls have longer hair, and so this is actually trying to get to an example of where this is bimodal. Okay, and if it could be skewed, I would if we're talking about the direction of skewness. Again, I can't get shorter than 0, so I can't skew this to the left. However, I could have hair down to my mid-back, hair down to my butt, hair down to my ankles. In reality, I think that would be a pain. So it could say it was skewed right. Okay, and there we go. Here, guys, short. I know this is stereotypical. Girls long. Okay, there we go. The histogram will display shows the sugar content as a percent of weight of 49 brands of cereal. Describe this distribution. So again, in describing this, we have to remember our socks. So S, O, C, and S, socks. Okay. This first one again is going to be shape. The shape of this is going to be, what are we going to say the shape? Again, I have a distinct mode here and a distinct cluster here. So since I have those two clusters, this is going to be bimodal. Outliers. And I'm just going to put no apparent outliers. Center. So again, there's a couple of different ways we could go. In reality, if I talked about the center is going to fall right about here. However, there's not very many cereals there. So I'm going to talk about the center of those clusters. All right. So there's a cluster at 8% sugar. Okay, here. And then there's another one here at roughly 45%. And lastly, the spread, we could have the super great tasting 0% sugar to, I'm sure it's delightfully tasting, delightfully sweet, 64%. Okay, so again, I'm fine with, you could put 64% for an answer as far as the actual range itself, or I'm fine with stating 0 to 64. If we were taking AP stats, I'd make you say 64, but we're not. So there we go. I'll take either one. What do you think might account for this shape? Again, this is where there's no wait time here, but children's cereals are typically higher than sugar. Than adult cereals. Oh. Adult cereals low in sugar. Okay, that's all we're done. That's all I wanted to address was shape. I guess we had to do the whole thing. Never mind. All right, 9. The histogram shows us that, and again, if I move too fast, you got the easy part. You can just hit the pause button on me. The sizes, the histogram shows the sizes in acres of 36 vineyards in the Finger Lakes region of New York. Approximately what percent of these vineyards are under 60 acres? Okay, so again, we got to look at our scaling. It looks like we come out here to a 120, and we started at 0, and there's 1, 2, 3, 4 divisions. So I think that should go by 30s. So there's 30, here's 60, and here's 90. And so that'll be 120. So that works out. Okay. So that means that we're talking about a division marker right here at 60. Okay. Under 60, it looks like there is 15 in this particular bin. There is 13 in this particular bin. So that means that there are 28 total below 60. Okay. So that means that 28 is going to be my numerator. It says that there's a grand total of 36 in my graph. So 28 divided by 36 gives me 78%. Write a brief description. Again, this is going to be shape center spread. Anything unusual is kind of this book. What we do in this class, if we were in AP stats, it'd be socks BS, meaning socks be specific, meaning we have to include context and all that fun stuff. Okay, but here we go. Our socks. So first of all, the shape is going to be unimodal, skewed right. Outliers. Ooh, we have a one really large lake. At 200, actually, no, it's not a lake. It's a vineyard, isn't it? I guess we'll be better be specific here. I'll squeeze vineyard in here. At 240 acres. That definitely stands out. Okay, the center. The typical, what is your typical? About 30? Sure. and the spread. Now, this is unfortunate. Again, this is a part about a histogram that makes it hard to read. If you look at my bin goes clear down here to 0. And the question is, can you have a vineyard with 0 acres? Well, I would have to say there wouldn't be a vineyard then, but since that's what all we can see, we're going to say 0 to 240. And again, that which is about 240, and that would actually let us, if I had, if it's like 1 or 2 acres in size, I'm sure this is like 241, 242, or who knows how. It's 30 wide. It could go all the way up to 270. Excuse me, I gotta quit that. Okay, but anyway, and again, I'm not going to turn this into rocket science. As long as I can think you understand what we're talking about spread, then I'm going to be okay with what you put down. Okay, all right, moving on. 11. The histogram shows the length of hospital stays of the female patients admitted to the hospital in New York with 1 year with a primary diagnosis of acute myocardial infarction. My favorite word to say of the whole class. Anyway, it's a heart attack. From the histogram, would you expect the mean or the median to be larger? So this is the part that we haven't got into a great deal at all. So here's I need to delve off into a little bit about mean and median. Now, earlier I said the mean was our middle by average. We said the median was the middle by position. So let's talk about the two different things here. And I always use age to use my explanation here. And we would find the average age of students in the room. Okay. Now, the students in the room, you're all 16, 17, or 18. So I'm going to say that the mean age was 17.5. Here, let's do this. Let's do this. So let's say that there was 16, 16, 17, 17, 18, and 18. Okay. So that mean, the mean equals 17. Okay. Now, if we talked about the median, so the median is my middle number. So if I have a 16 and I can actually just count in. So there's one on the outside, one on the outside, this one come in, this one come in, this one, this one. So that means my median falls right there. So my median is also 17. And I was expecting that just because it causes wow, I don't even know where I was going. Okay. My mental capacities probably aren't the best right now, but we're going to live with that one. Okay. Now I'm going to throw on another number. So we're going to throw in that 7th person. I am going to throw on now. We're going to talk about people in the room. So now we have to throw in the old man here at 50. Okay. What did that do to my mean? Okay. So now my mean, and I'm going to change colors now. I'm going to change this to red. And unfortunately, I need a calculator to do this. So let's go over here to my calculator. Okay. I'm going to jump out of this. And we had 16 and we had 16. Syntax error. How could there be syntax error there? Clear. I don't understand this, but it's a new app. We're trying it. I don't know why it says syntax error. Oh, okay. I gotcha. It just automatically does that for me over there. So the total is 102, but then we're going to add 50 to that. Okay. And now we're going to divide that by 1, 2, 3, 4, 5, 6, 7. So we're going to divide that by 7. And the mean is 21.7. So if I come over here, my mean now becomes 21.7 because I was way, way older than any other people in my group. However, if I talk about my median, now again, we start on the outside. There's one there. Actually, let's do it the real way. Okay. I had 7 pieces of data. We're going to add 1 to that. We're going to divide that in half. That'd be 8 divided by 2, which is 4. So that means the 4th number, 1, 2, 3, and 4. This number here becomes my median, and it is 17. So what happens is medians are going to be resistant to outliers is the moral of the story. Okay. And a high value in the right causes my mean to go with it. Okay. My mean jumped all the way up to 21.7. So in the histogram, would you expect the mean or the median to be larger? So again, if I have a perfectly symmetrical set of data, my mean and my median are going to be right there, the same number. Okay. However, once I throwing in these high numbers here, okay, so my mean and my median are going to start together here in the middle, but once I start throwing the high numbers, my mean is going to get pulled in this direction. All right. So I'm going to expect my mean to be greater than my median. Okay. All right. Write a few sentences describing the distribution. So shape, center, spread. Shape. If you want to roll with bimodal on this one, I would take bimodal because I'd realize you recognize there's this guy right here does not fit. It's its own little separate thing here. Okay. But that's what we're going to do there. This is also skewed right. So outliers. Okay. We have some really large numbers out there. So yes, we'll just say really long hospital stays. I really don't know how long that actually is. We have a way of calculating an outlier. We'll get to that later, but right now we just got to say they're outliers. Center, what's our typical hospital stay? I was going to say somewhere about in here, so I'm going to say about 8 days. And then the spread. Looks like we got 1 to 37. Okay, that works. Which summary statistics would you choose to represent the center and spread of these data? And this becomes a really tough question right now because we haven't really done a good job of talking about center and spread because our notes haven't done a good job of that. For center, there's two things for center. There's a mean and there's a median. Okay. Here's the part that we haven't done at all yet. The spread is done by the standard deviation and what's called the interquartile range. And we're just going to get through this problem for now, and we'll explain some of it later on. But in this case, because it is skewed right, we're going to pick a median and we're going to pick the interquartile range because it is skewed to the right. Okay, so again, that one's we're going to have to just leave in the dust as far as it is probably a little bit out there right now. But we'll get to that. We can do mean a little bit right now. Okay, if we talked about the mean age of people in the room, 21.7 or 17, which one's a better measure of the age of people in the room? Well, 17 is the better age of people in the room because it's my 50 years old there is pulling my mean way up. Okay. My interquartile range actually represents the middle 50%. So that's why that is a measure of spread as well. So versus the standard deviation, we haven't got on the calculation of standard deviation. So I'm just gonna leave that alone. Let's move on. Okay. Here, finding the medians and the quartiles. So we have a list of 42. So here's this is going to be a little bit hard virtually, but we're going to give it a shot. Okay, as far as what this is, if we were to do this by hand, we would have to put all my numbers in numerical order, and then we'd have to start chopping it up as far as finding the median. But we're going to do something different. Okay, I warned you we needed to get a graphing calculator. Okay, so if you have a graphing calculator, bravo, this is, we can work with this. Okay, however, I had the school librarian load on, it's called, you can see it in the middle, it's a little bit pink, I can't point at it very good, but it's calculate 84. Okay, it's set up there. It is in your Mosul manager. So if you might have to refresh your manager, but if we load this, I believe we can do everything that we need to do in this class can be done through the free version of this app. Okay, the paid version of the app makes it is much more robust and it's usable for AP stat. But the free version, I think, will get us through this class. So we're going to hope for that and go with that. And then if we hit a roadblock, we'll adjust then. But having a graphing calculator would probably be the best option for that. Okay, so what we're going to do is we're going to enter data into a calculator. So here's where we're going to go. And this is really hard because you're not going to see me point, but because I don't have a pointer here. But here in the middle, if we have the alpha on the left, we're going to go over to from there, and there's a stat button. We're going to hit stat. Okay, and from stat, we're going to hit edit, which is number 1. Okay, and we see this works exactly like an Excel spreadsheet does. Okay, so here we look on the left, it's L1. I've already taken the time to load in all of the Super Bowl scores already, so that is done for me. Okay, the only thing I want to point out again is how to check yourself to make sure you got them all entered correctly, all entered anyway. You can see that I'm on L1 and 43. I had 42 pieces of information to enter. So I've got the correct pieces of information. Now, nothing's to say I couldn't have blubbed one of the numbers up, but that's what it does for me. Okay. So we're not going to do anything by hand in this class. Our calculator is going to do it all for us. So I'm actually not going to go through the hand calculation of it, besides maybe just a little bit of an explanation. Okay. But anyway, I'm going to go to second and I'm going to quit. So we're going to go back to our main screen. I'm going to clear that out. I'm going to clear the whole thing out by hitting it twice, and we're going to go from there. I was asked to find the median and the quartiles. Okay. So if I were to do this by hand, again, what would I do is I would do them all out numerically. Okay. And what would happen is I would find that number. I would divide it into half. I want to find the median. The median is right about here. And what happens is this. So this is my median. So I have the lower half here. If I cut the lower half in half and I cut the upper half in half, basically I split that into 1, 2, 3, 4 equal chunks, or I have quartered it. So that means this is quartile 1 and this is going to be quartile 3. So that's how we would do that by hand. We'd run out all those numbers in numerical order. We'd start chopping them up. We'd chop it into 4 equal groups, and now I'd have my quartiles and my median. However, my calculator is going to do that for me, so we're going to let it. Okay, so we're going to go back to our calculator. We're going to hit that stat button, except now we're going to go over to that middle menu and to calculate. And we're going to calculate a one variable statistic. So I'm going to hit number 1. Now, if I look, my list was stored in list 1. And again, this is really hard with doing it virtually, but if you look above your 1, 2, 3 keys, there's a L1, L2, and L3. That's how we can get those entered up there. But we need to make sure that we're populating this list 1. The frequency list, we are going to leave blank. So I just have to hit enter. And if I look over here to the right, it gives me everything that I need to know. Okay. It tells me that my median is 45, my quartile 3 is 55, and my quartile 1 is 37. Okay. So that means if we go back and fill out our notes, my median was equal to 45, my quartile 1 was equal to 37, and my quartile 3 was equal to 55. And I apologize. I was going to encourage you to pause and enter that into your calculator. But I would definitely, just watching somebody do it's a lot different from just doing it yourself. So I would definitely try to do that. Okay, now here's the advantage of our calculator. It says write a description based upon the 5-number summary. So let's go back to that 5-number summary. Okay, now what we're going to look at here is we can scroll up and down a little bit. Okay, what we're looking for is at the very top number here, the mean is 45. My median is 45. So when my mean and my median are roughly equal, I typically have a very symmetrical looking graph. And you know what? We have the data in our calculator, so I am going to let it fly, and we're going to look at this. So what we're going to do is we're going to create a stat plot. So if you look above on the very top left corner, it says y equals, and then stat plot above that. So I'm going to hit second, and I'm going to hit stat plot. Okay. Plot 1 is what I'm working with. I have to go here. Oops. I have to turn it on first, so make sure you turn it on. We hit the enter button above the on. It's going to be in blue. I'm going to create a histogram, which is that middle graph. Okay, frequency is 1. My list is L1, and I'm going to hit, and now I'm going to hit graph. Okay, now that looks a little bit funky. Okay, actually, it looks really funky right now. So I'm going to hit zoom, and I'm going to hit 9 for zoom stats. So it's going to zoom it around the stats that I have. Okay, now I'm not a big fan of what it did for me there. Okay, so I'm going to go into the window, and I'm going to look at the window a little bit, and I'm going to arrow up, and I'm going to change a few things just because I didn't like that. So the X min, so I'm going to start this at 0. The X max, what was my maximum score? I don't even remember. I see a 69 in there. 80 should cover it. So we're going to go clear and 80. The X scale. So what happens with the X scale? The X scale is how wide each bin is. Okay. And so I'm just going to go, I'm going to clear that out, and I'm going to put a 10 there. Okay. And I'm going to set my Y min to, just so I can see more of the graph, I'm going to put that to 0, and I'm going to put this to, let's say 20. I can't imagine it'll be higher than that. I'm going to go back to that graph. And this is a much better picture to look at. Okay. I can see a lot more. Okay, so this is unimodal and symmetric. Granted, yes, it does appear that's a little bit, if I don't know what this is doing. Oh, okay, I double tap it. If I click on that, this is my first time using the program. So it's telling me how many pieces are in each bin. Okay, so there's 8, there's 11, there's 5 in that one. Okay, If I come down here, you can't see me point, but you can see me move it. Okay, that's n equals 5. Again, it's showing you between 20 and 30, et cetera, et cetera. So usually we get that by hitting the trace button. But again, we'll learn more, but hopefully learn more about the program. But that's not what I needed now. I just needed a picture of it. It does appear maybe a little bit skewed right. So we'll put that. So we have to describe this. So the shape is unimodal, symmetric, with slight right skew. There are no apparent outliers. And the center, my mean and my median are roughly equal, so it's 45 points. And the spread, I forgot what's my min and what's my max. It's 21 to 75. I'm fine with that. Or if we want to write that difference, that is 54 points. All right, so all of this is really about, we're going to do a separate worksheet to really work on our calculator stuff. This is all about trying to understand the picture that's created with our calculator. So if we didn't get that out of your calculator, it's going to be okay. We're more worried about being able to understand the picture. Okay, so here we go. Let's roll through the rest. I don't know how long I've been yapping, probably too long. My voice definitely hurts, but we'll roll with it. Shown a histogram and summary statistics for the number of campsites in which statistics would you identify the center and spread and why? So again, this is going to be, we have this large skew to the right. These outliers are going to cause my mean. Okay, so remember, when I have a perfectly symmetrical set of data, my mean and my median are going to be here in the middle. But once I start stretching this out, it is going to pull the mean is going to get pulled with that direction. So this would be my mean is greater than my median, and it's typically we don't use it then. So when it talks about the center and the spread, my center, okay, is going to be the median, because my mean is going to be, it's going to overestimate the number of sites per park. Okay, just like if we went back to my classroom data, the age of people in the room, that 21.7 overestimates the middle, because my 50 years old jacked that way up. Okay, so we're going to say the median, and then we're at the inner quartile range is automatically paired with that. Okay. And there's outliers out there as well. All right. I feel like I'm getting monotonous and boring, so we're just going to plow on through and get this finished, though. How many parks would you classify as outliers? Okay, so here's our first foray into outliers. I think what happened was I need to look at the packet I gave you, because I bet this is where it's a little bit off, because we didn't talk about outliers and anything that you read, because it's probably in chapter 4 instead of being in chapter 3, and I need to get that straightened out. However, here's how we classify outliers. Okay, we have a lower boundary that's found by taking quartile 1, and we're going to subtract away 1.5 inner quartile ranges. That would give me an outlier on the lower side. We can also have an upper boundary, and that is found by taking quartile 3 and adding on 1.5 inner quartile ranges. Okay, so I need to grab my eraser here. I don't need this picture anymore. Okay, and so in this particular case, we are going to be given the quartiles over here, okay, at 28 and 78. So my lower boundary is quartile 1, which is 28, minus 1.5. My inner quartile range is going to be the difference between the quartiles. Now, if we talk about that for a second, okay, I'm going to plot this box plot, because that's what we're into, is we're getting into box plots. Okay, if we scaled this, okay, here's 10, here's 20. How high do I got to go? Max is 275. Okay, I'm not scaling by 20s. Not definitely do that. Okay, so here we are, 0, and here is 50, and here is 100, and here is 200, and here is 300. So there's my scaling. Okay. It says that my minimum is at 0. My quartile 1 is at 28. My median is oh my gosh, I'm gonna call. I'm gonna pause this for a second. Can I pause it? All right, now so I'm pick up where I was left off. Should yeah, get myself back together here anyway. Sorry, I had to take that phone call. So not that it mattered because you didn't know because I paused it. So I just need to shut up and move on. Anyway, my median turned out to be 43.5. So my median is going to fall in roughly right here. No good. My pen's going to die right now. Are you serious? Okay, I'm going to be out of luck. Okay. What's quartile 3? Quartile 3 runs in here at 78. So we're going to assume where 78 is. Yeah, my pen's not going to work now. Gosh darn it. My max. Okay. My goodness. Okay. So I need to, what am I going to need to do here? We're going to pause this again and I'll try to pick up and we'll hope for the best. Okay, let's try again to resume. I got some charge in my pen now, so we'll keep working with that. So we're over here making the box plot, but unfortunately, I'm a moron here, and realize that over here in part C it says create the box plot. So it's horrible. I'm doing an absolutely knockout job on this, but we'll do our best. Anyway, we're going to max this out at 275. Okay, which is going to be what, right about here is my max. Okay, so in reality, this extends all the way out here. Okay, so this actually does a nice little job for us as far as explaining what we need to do here. Unfortunately, I just drew the box plot in the wrong darn spot. Okay, so remember this is quartile 1, the edge of the box. The other edge of the box is going to be quartile 3. So what we're saying is we have the length of this box. Now, actually, let's back up 1 second here. Let's talk about the inner quartile range here. The inner quartile range is going to be the inner quartile range is quartile 3 minus quartile 1. Okay, so in here, that's really, really easy. That's going to be 50 because we're going to take 78 minus 28. Okay, so that is the length of the box. The length of this box is 50 units. In this case, 50 acres, number of sites. So 50 sites. Okay, now that represents the middle 25%. Because when we split it up into quartiles, I have 25%, I'll highlight it here, 25% in here, 25% here, 25% here, and 25% here. So what did that, again, it represents the middle 50%. Okay, now we're talking about an outlier, determining what an outlier is. So I have this length here, this length is 50. So what happens is I'm going to take that times 1.5. So 50 times 1.5 is 75. So from this mark here, oops, I still have my highlighter on, I don't want that. I'm going to go 75 units this direction, okay? And so I'm going to put a cutoff there. So I actually forgot where I was at, 78. So actually, we're going to figure my upper boundary next. Upper boundary, I started with 78. I went 1.5 inner quartile ranges, which was 50 up, okay? So 78 plus 75 is going to give me 140, 153. So at 153, see, I was actually pretty close. Okay. Get my eraser here. I'm going to get this cleaned up. Okay. So at 153, there's my boundary line. So I have drawn my whisker way too far. So my whisker is not going to be that long. Okay. So that means that I'm just going to draw my whisker out to this line because I have no idea where my other points are. Okay. And this is going to be considered an outlier because it is more than my boundary line. Okay. If I go 1.5 interquartile ranges the other direction, so I'm going to go 75 units this direction. So that's going to be, what's that going to be? 28 minus 75 is going to give me some number that I have written down here, negative 47. So that means down here at here's negative 50. So I about drew it in the right spot. There's negative 47. Obviously I can't go less than 0. So I wasn't going to have a lower outlier. So man, I'm really stinking this up bad. Anyway, describe it. So again, we describe it as our socks. So we're gonna get the shape of this. Again, it's unimoto skewed right. The center. The center is about. And if we come up here and look, again, I put the center right in here somewhere. So I said it was, for some reason, in my notes, I have 43.5 sites. Oh, I know why. Because it is skewed, we're gonna go off my median. My median is 43.5. Okay. Yeah, I don't think there's such thing as a COVID fog, but I'm beginning to realize maybe there is. My brain is just not firing on all cylinders. Outliers. So we can see that from this, okay? We're talking, what do we take? Anything above 153. So that means this guy's an outlier, this guy's an outlier, and this guy's an outlier. So I'm going to have at least 3 outliers. They are at 180, 200, and 275. And then I didn't leave much room for the spread. The spread, and since we're going to go the interquartile range, because it's skewed to the right, we're going to use the interquartile range. And if you had said from 0 to 280, whatever that number was, I'd have been fine. All right, I have just murdered that problem. Okay, let's try again. The box plot shows the fuel economy ratings for 67 model year 2012 subcompact cars. Some summary statistics are provided. The extreme outlier is the Mitsubishi whatever, which is an electric car whose electricity usage is equivalent to 112 miles per gallon. If that electric car is removed from the data, how will your standard deviation be affected? Oh my gosh, how have I done this to you and not explained what standard deviation is? Okay. All right, so this is, oh man, this is gonna end up being a long video. It is what it is. Okay, let's go back to that set of data again. Okay. Let's talk about, no, you know what? I'm just going to go, I'm not going to do an example of it. I am just going to talk about standard deviation, a definition of standard deviation. Standard deviation is going to be your average distance from the middle. Okay. So basically what happens if I said, let's go, if I went back to this age problem up here, wherever that was up here, okay, 17, okay, how far this unit, this guy is 0 units, and this guy is, both of these guys are 0 units from the middle. This is -1 below, this is a -1 below, this is 1 above, and this is 1 above. And then I would find that average distance each piece is from the middle. Okay, that's what I'm doing when I find a standard deviation. So what's going to happen is this piece right here is a long ways from the middle. So when I figure out the average distance, this piece is contributing a ton to that average. So if I remove that piece, my standard deviation has to get smaller. Now, because I removed this piece, more than likely my positions don't change a ton. So we're talking about my interquartile range here, and that should stay the same. All right, man. 2 more to go. Let's get this over with. I'm sure if you're still awake by now, I hope you're still awake. All right, a clerk entering data into the company spreadsheet accidentally put an extra 0 in the boss's salary, listing it as 2 million instead of 200,000. Explain how this error will affect the summary statistics. So there are measures of center. So again, here we have our pieces of data on a number line. Okay, there's going to be a few pieces here. A few people make this, a few people make this, et cetera, et cetera. Okay, those are my dollars. So instead of the boss being here, she accidentally put an extra 0 and put the boss. That makes the boss clear out there. What's going to happen to my median if I take this piece and move it from here and move it clear out there? My median is going to still be right there. It's going to remain unchanged. However, my mean, since my mean has to do with the sum of all of those numbers, and this is a large sum, my mean has to increase. So measures of range. Range is going to be max minus min. So my range was from here to here, and now my range is from here to all the way out here. So therefore my range had to increase. My interquartile range, my middle 50, let's change colors. So here's one in the middle, here's the other middle. So there's my interquartile range, but I moved this guy from here, clear out here. Did that impact my middle numbers? It did not. So that means my interquartile range is going to remain the same. And lastly, my standard deviation. And again, my standard deviation is my average distance from the middle. This point was only this far from the middle. Now it is this far from the middle. So therefore it added a huge distance from the middle. So therefore my standard deviation has to increase. All right. And lastly, the histogram shows the total gross earnings millions major release in 2018. And industry publication reports that the average movie ticket makes about 41.7 million, but a watchdog group concerned about the rise in ticket prices says that the average is 69 million. What statistics are each group using and why? So obviously we see something that is quite skewed to the right. Okay. Now one group says the middle is 41.7. One group says it is 66.9. How can they both be right? Okay. So 41.7 is likely the median because that's going to be my middle by position. And then 66.9 is, man, I am roaring through here, not writing neatly at all. It's like the mean. It's the middle by average. It is pulled up by high outliers. All right. I've done as much damage as I possibly can to you. Thank you for sticking with me this long if you have, and I hope you all have a great day.